Hello, my name is Steven, and I'm going to be making up the geometry video. How about we get right into it? First order of business is to define some terms. The first term we're going to define is or comment on is a point. Now, a point cannot really be defined very well. For example, if I draw that and I call it a point, that's really not true. A point is supposed to take up one space in the screen, in the monitor, in your computer screen, your television screen. But let me draw this a little bit bigger. Let's blow it up, magnify it. There's definitely a center to that point. Well, if a point is only supposed to take up one place, whatever place is, one place on the board, well then how can there be a center? For example, if I draw that, imagine it was filled in and I said that's the point. Well then what's that in the middle? What's that? That has to be a point. It's even smaller than the original point. This point that I initially put down, that circle, is made up of a lot of points. When I put that dot down, it does right there, it does not represent many points. It represents a number of points. For example, if I put a lot of dots together, you might say, oh wow, you're really good in drawing a single point. That's such a nice looking point. But in fact, it was made up of many points. The point I'm making is that the thickness of my marker, the thickness of your pen, your pencil, your very thin pencil or pen, very fine pen, isn't fine enough. I can draw, that point in theory can be drawn a lot thinner. So a point is not very well defined. But fortunately, we all have a very, very good intuitive idea of what a point is. So let's not get too carried away with the fact we can't define it. What we're going to talk about now is how we name points. I just drew what looks to be like 6 points. I said look to be, maybe I counted them wrong, but there are 6. When you label or name a point, you use capital letters from either the beginning of the alphabet or sometimes from the end of the alphabet. But either way, we label points with capital letters. Now what we're going to talk about is the next term, which is a line. And in mathematics, we always have undefined terms. And everything after that is based upon those undefined terms. A line is a set of points that are straight, that lie on a straight edge. For example, that's a line. And a line, well actually that wasn't a line. A line goes in both directions forever. That is, you may not see it, but this line's really going further and further. It's going way past the board in both directions. But what are we going to do? Be here forever, drawing a line to the right forever, and then once we go to the right forever, now we're going to go to the left forever? We can't do that. So what we do is we draw a very small part of the line. After all, if this line goes on forever, that's a pretty small part. Even if I use up most of my whiteboard, that's a pretty small part of the line. You put arrows on the end to signify that it's a line. Now, what we're basically doing now is defining these terms and most importantly, how to name them. How would you name this line on the bottom? Well, you can call it L for line. That's one proper name to call it. Or, now, sometimes, or most times, it's not every time, I draw this picture, and I ask somebody, how many points are on this line? And probably 100% of the times, people will tell me 2 points are on that line. Well, to be honest, that's ridiculous, because a line has an infinite number of points. There's a point here, and 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 then many to the right of what you see, and to the left of what you see. What's correct is that I highlighted 2 points on this line. But nonetheless, this nice straight line, it has an infinite number of points. This nice straight line has an infinite number of points, 2 of which are A and B. We can name the line AB, and we put a line symbol on top. Arrow to the left, arrow to the right. Line AB. So line L can also be called AB if you were given 2 points, at least 2 points. If you get some other points, you can call it AB or AC or AD or CB or CD or even BD. These are all proper names for this line L. 1, 2, 3, 4, 5. 1, 2, 3, 4. Yeah, there are, in this case, 7 different ways of naming line L. 1, 2, 3, 4, 5, 6, 7 different ways of naming this line. You generally shouldn't name it DB. Well, actually, I guess you can, because I want to say, well, if the line is drawn horizontal, you should put the left and then the right. But, if the line is drawn this way, we're going to argue which is to the left and which is to the right. I mean, left goes this way and right goes that way, so I would say that B is to the left of D and call it BD. But let's not get caught up with that. If you have 2 points on a line, you can write down both points and then put a little line on top of it. That little line on top better have both arrows. You should put the line symbol on top. Pick any 2 points on the line and then put a line symbol above it, and then that's one way of defining the line. The next thing we're going to talk about is array. Array is a little different. It's a portion of a line. Array has a starting point, for argument's sake, call that point A, and it goes in one direction forever. Goes in one direction forever. If you happen to know another point on the array, let's call it point B. If you happen to know a second point on the array, you put down the starting point, you put down that second point, and you draw a array symbol. If you knew a third point on the array, you put down the starting point and any other point on that array that you know. Whether it's B or C or D, it doesn't matter. You can go AD. You cannot go BC. You cannot go BC. You cannot. That is not equal to the other arrays. The array BC means it starts at B, let me draw it up here, and it goes in that direction forever. That is, it is only this portion. But that's not what I initially gave you. What I initially gave you started at A. So that is why it's not BC. You must put down the starting point. Now, if array starts at B and there's some point D eventually, you still write down the starting point first, B, and then another point on the ray. And you put the ray symbol. That would be the ray BD. Don't say, well, D is to the left, because if you write DB, if you wrote that, well, then what you would be meaning, or what that would represent, is what I'm putting in red right now. You start at D, and you go in the direction of B forever. That's not what you were given. What you were given, I'll draw it right below, started at B and went to the left forever. They're not the same. What you see down here in black and what you see above in red, they're not the same. They go in opposite directions. So they're not the same ray. You put the starting letter first, and then the finishing letter second, and then 1 point on the ray second. A ray has a starting point. The next thing we're going to talk about is a line segment. First we talked about a line having no endpoints. Then we talked about a ray. It has one endpoint. Now we're going to talk about a line segment, which has two endpoints. Line segment AC. AC. Just put a line above it with no arrows. This line segment AC. If you had B somewhere in there, it's still AC. You have to list the start and the finish. It's the same as CA. It's the same as CA. You have this line segment, X at one end and Y at the other end. You can call it XY. You can even call it YX. But put the line segment symbol above it. At both ends, there's two endpoints. There's two endpoints. There are two endpoints. Imagine you see a group of people in a line. They're about to race. They're about to start a race. And they're running that direction. Well, which would you call? So, they're in this line. It starts here and it finishes right there. Well, which would you call the start and the finish? There's no reason to call that person the start and that person the finish, or vice versa. There's no start and finish, because it isn't like they're waiting online to buy something from this booth over here. Then this person would be first and second and third and fourth and fifth. That would be obviously true. On the other hand, if they were waiting to buy something from that booth and there was no booth here, then this person will be first and second and third and fourth and fifth. But they're running to the finish line. Or they're starting the race and they're going to run to the finish line. So there is really no first or second on that line. Or start and finish. Like if they go into this booth over here, then this would be the start of the line and this would be the end of the line. Of course, if you wanted to wait online to buy something from here, and you're coming now, it'd be quite rude to go there. Why? Because that's the front of the line. That's the start of the line. You should go there, to the finish of the line. But now, think about it. If you came and there, you have this very, very big field, at least as big as what I just drew, and you saw somebody standing here and another person here, and not much space in between two people, not much space in between two people for you to come. And here you are strolling along, and you're like, oh, I'm one of the contestants in this race. Let me get in line. Now, I don't think it's very clear to you whether you should go there or to there. In fact, I think you would pick either or, because there is no start and finish. I'm making a big deal about this, but a line segment, it has a start and an end, but you don't know which is which. It doesn't matter. A, B, that's line segment A, B, which is the same as BA. Now, let's talk about something else now. Let's put this all together, that is. Suppose I draw a line. I give the line a nice name like L. I put some points on the line. Be a pretty boring line if it had no points on it. Well, excuse me. I am labeling some of the points. The line has an infinite number of points. And you're being asked to draw certain things. Draw ray, draw that ray. That's an error. I don't think it came out well. And you really shouldn't draw it underneath, but since I'm going to draw so many different things, I'm not going to keep redrawing that line. But basically, you should put a dot here and go and start at A and go in the direction of B. And there it is. You don't have to go that far. Okay. For the record, and I would draw it longer, but for the record, you could have just drawn it that long. One gets the point. It starts in A and it goes to the right. But let's draw it longer. Again, it doesn't matter at all. If you were asked to draw DC, the ray, that means it starts at C. Sorry. It starts at D. It starts at D. And it goes towards C. C is towards the left. C is to the left of D. So you go to the left forever. And that's ray DC. If you were asked to draw line segment AD, you start at A and you go to D. Or, if you preferred, you start at D and you go to A. Either way, you get the same. If you were asked to draw AC, or line, well, you can say I already did that. It's line out. But basically, you draw a line that contains the points A and C. And if I'm going to draw that again, here it is. That's line AC. But again, I mean, if it was my problem, I would just say, oh, it's there. It's L. I already labeled it. It's L. Given, you can say it's the given line. Just make it clear to your teacher that you know what line AC looks like. It looks like the given line. How can you be marked wrong for that? Or sometimes you would. I should say, why should you be marked wrong for that? Okay. Now, let's change these type of problems that I'm asking. We're still going to have this line. We're still going to have this line. Let me erase it on my physical board. And now, so now union, it means to add on. If you have line segment AB, union is that symbol. It means union, which means add on. If I have line segment AB and I say to add on line segment BD, well, you'll see in a moment, I hope, that you get line segment AD. And just get your hands dirty and do it. Here's line segment AB, and I add on, I have AB, and I add on BD. I start at B and I go to D. And I say, oh wow, look at that. I'm going from A all the way to D. I can just go from A to D. And that's called AD. If I have AC, and I'm being asked to add on BD. Sometimes you add on duplication. You add on something, or you attempt to add on something that's already there. Okay, B, C, and D. So we have AC, lines, oh, sorry. We're going to add on, we're going to union those two line segments. So here is AC, here is AC, and then I'm going to add on, so there's AC, I'm going to add on BD. I'm going to add on from B to D. Okay, add it on. So it turns out that BC got added on twice. We don't care. We don't care. We still get from A to D. Okay, let me do that again. You have all the points from A to C. All the points from A to C. Line segment AC, and you add on, union, add on the points from B to D. You add on the points from B to D. Any point on the number line that has a mark next to it, we include. Well, that's everything from B to D. Excuse me, A to D. So it's line segment AD once again. Sometimes it's disjoint. You have AB, union, DE. So the instructions are to draw it and to simplify it. For example, I simplified number 2 to just AD. Number 1 I simplified to also coincidentally AD. Now this one I'm not going to be able to simplify. I'm not going to be able to give a clean answer. But you can always draw it. You can always draw it. D, C, B, and A. So it's AB, which is this. Here's AB. And I add on DE. And there it is. I drew it. But they're not intersecting. There's no overlapping. It's two separate pieces. It's this piece and that piece. So you can't simplify that. You can't simplify AD union DE. It's just that. And that problem is done. So union means to just add on. If you, and those were line segments, excuse me. What if you have ray, let me not do that. What if you have ray BC, starts at B and it goes in the direction of C, and you want to add on EA, line segment from E to A. Now, please remember the line segments go forever in one direction. Line segments, they go forever. So I would draw each of these line segments and see which points they combined, they both combine to. B, C. You start at B and you go in the direction of C. I'm starting at B and I go in the direction to C forever. It's all of those points. All points to the right of B. That's those. Now I start at E, I add on, starting at E, going to A. So I start at E, and I go in the direction of A, forever. I start at E, and I go to the left forever. Okay, well that's the graph. And the answer is, the simplified version is just line A. I mean, look at every point on that line L is red now. I highlighted B, ray BC in red. That was all of these points. And then I highlighted EA, so I started at E. And ray EA, I started at E, and I went to the direction of A forever. And I got all of line L. So you need to be able to do things like that. Next, we are going to talk about intersection. We're going to talk about intersection. Intersection, denoted by an upside down U. And here we look for not add-on, but overlapping. Where things overlap, you found it, that's the intersection. So again, we're going to have a line, line L, very famous line. You have some points on the line. These say 5 points. And you want the intersection of line segment BD intersected with line segment CE. Which points do they have in common? Well, BD has those points in common. Notice I drew them this way. CE, I'm going to draw that way. Now we're going to now we're going to put CE. C to E. And we look for overlapping. Well, when these slashes are combined or intersect with these slashes, what you get is that pattern, which is between C and D. That's the intersection. Now, the top graph, let me write this a little bit lower. Okay. Now, let me write it lower. Now, this top graph or number line helped us in finding the intersection. It helped us find the intersection. But sometimes your teacher wants you to graph the solution. Although that graph, that number line graph in front of you, or line graph in front of you, I didn't mean to say number graph. Since that line graph in front of you helped you find the answer, that was good. But the final answer, like we said, is CD. And you should draw this as your answer. Okay? You should draw that as your answer. CD. Graph the intersection. Oops, that doesn't look like a D. Graph this and simplify it. Well, there's the graph, and here's the simplification. This graph was a tremendous help in finding that intersection point, but by no means did it help. The reason I would not accept this graph as an answer is because what if the problem said to find a union? To find a union. What if it said, find a union, please? Well, what you would do is you would first draw line segment BD, which I'll do in red. Draw line segment BD. Notice that's part of what I already had. Now draw line segment CE. CE. Notice how I'm drawing it differently. It's a different different line segment. Let me draw it differently. Now this time the answer is not where it's overlapping. It's the collection of points that have any markings above them or on them. And that's line segment BE. That's line segment BE. Now, the problem is that that graph on top, that line graph on top, looks exactly like the one where it had intersection right here, where it had intersection. Well, we can't allow that. So we really should come and draw a final graph and say, it's all the points between B and E. Which, by the way, looks exactly what I have over here. I'm highlighting everything from B to E. If you left that, that would be fine. But if you want your teacher to decide for themselves where the intersection is, well, I would think no. That was the question. Where does it intersect? Your teacher shouldn't be answering your question. So you can find intersections of rays and lines and line segments, as well as a union. One more union. Suppose you have this, union. Suppose you have these few points highlighted, and you want to find the union of, ray CD with the ray BC. You want to find the union of those two rays. And you want to simplify it. And if you can simplify it, well then, that's just the answer. Well, ray CD, it starts at C, and it goes towards D. That is, it goes to the right forever. Oh, but by the way, this was a line initially. Initially, it was a line. And we just drew line segment CD. Now we just drew this. Now we're going to add on, I meant to say we drew ray CD. Now we're going to draw ray BC. You start at B and you go in the direction of C forever. That is, you go to the right forever. And basically, what you have is from B to the right forever. Whether you write BC or BD, they're the same answer. They're the same answer. If there also was a letter E, it's BE as well. And these two line segments I wrote, you don't have to put dots at the beginning. It's understood. Starts at C and it goes to D. And that would be the union. And it turns out that the graph is already there. It's everything from B on. Let me draw it in the correct color. It starts at B and it goes to the right forever. That's the final answer. If instead of union, same exact problem, if I asked you for intersection, what would the answer be? Well, when you draw it, especially for intersection, you have to be careful because you're looking for overlapping. So somehow you have to draw it differently. Draw different colors, draw it using different symbols, but nonetheless C to D. I'll draw it above. You start at C and you go to the right because that's where D is forever. And BC, you start at B and you go to C forever. You go in the direction of C, but you go forever. Where do these two lines intersect? They intersect here. From C to the right forever. And that would be your answer. If you drew this, you should get full credit. Goes from C to the right forever. So its line segment from C to the right. You can say D, or you can say CE. Can't say CA, because CA goes to the left, and that would be wrong. Okay. The next thing we're going to talk about is a triangle. Actually, let's talk about angles first. If you have two rays that start at a common point, or two line segments that start at a common point, or a ray and a line segment that starts at a common point, you have an angle. Suppose you have two line segments and they both start at A, or A is one of the endpoints. One goes this way, say A to B, the other one goes the line segment from A to C. Well, there's an angle there. If, on the other hand, you have a ray that starts at A and it goes in the direction of B, and you have another ray starts at A and it goes in the direction of C, you still have the same angle. If instead of having a line segment from A to B, you have an A from A in the direction of B, and you have a line segment from A to C, it's an angle. You have to have at least one endpoint. From A to B, you can have a line segment, but A to C can be a ray, and you have an angle. Now, of course, you also have a second angle, the bigger one. But we'll talk about that more in 1 second. But first I want to say is that in the reading, it will tend to tell you which angle they're talking about. For example, if you have this small angle, well, what if it got bigger? Instead of going this amount, it goes a little bit more, so it's bigger. What if it got even bigger? Instead of going that amount, it goes more. Goes more. So now you have that angle. Coming up here, please. What if it's bigger than that? What if it's even bigger? Now you have that angle. What if it got bigger? What if it went this way? Now you have that angle. Well, what if it got even bigger? Instead of going this amount, it went a little bit more. What if it went like that? Well, if I would have initially given you this figure, you would have probably thought, that's the angle we're talking about. But it could have been that angle. Okay, there are two angles there. There are two angles. But again, they will make it clear which angle they're talking about. Now, how do we name an angle? A, B, and C. Now, I don't care if it ends at C, meaning it's a line segment from A to B, or if it doesn't end it, I might have said C, I meant to say B. I don't care if it ends at B, and hence it's line segment AB, or it's ray AC. Doesn't have to end at C, doesn't have to end at B, that doesn't matter. There are a few ways of labeling this angle. You can put a number here. Now this is the angle symbol. You can call it angle 4. You can call this angle just A, just angle A. Or you can call it, well, it goes from B to A to C. You could call it angle BAC, but we don't discriminate in mathematics. You can start at C and go to A and then go to B. And we call it angle CAB. There are 4 different ways of labeling that angle. In my opinion, the best way is angle 4. Because, again, I could have been talking about that angle. And if I were, I would name it. I'd name it 5. Now it's very clear that I don't mean this angle in here, but rather the bigger angle. So there are the few ways of labeling an angle. If you were to draw an angle without lifting your pen or marker, well, if this was B and this was A and this was C, that's exactly how you would name it. And name this angle here. You call it BAC. If on the other hand, maybe you went like this, you went from C, and then you went to A, and then you went to B, you can call it angle CAB. These are the same angles. They're the same angle. The angle you're talking about here, the letter at that vertex, that should be in the middle. So that's how you name an angle. Now, let's talk about a triangle. Then we'll even prove a theorem and that'll be it. Let's talk about a triangle. A triangle is a closed figure containing 3 line segments. Well, let's talk about a closed figure. That's a figure. It's closed. How do I know it's closed? Because I can pick 2 points on this blackboard, on this whiteboard, excuse me, say these 2, and I can't go from one, I can't draw from one of those x's to the other x's without lifting my pen. I can't draw some figure. I can't go, there's no path, that's the word I'm looking for. There's no path between the 2 x's without going through the figure. The path you take is up to you. You can go any old way you want. You can go any old way you want. I don't care how you go. But to touch that other x, you have to cross the figure. That's a closed figure. This figure, on the other hand, is an open figure. Now, just for the record, in this initial picture that I drew, let me erase the majority of it. In this initial picture that I drew, there are many points where you can get a path from one to the other. But if you can find even one path, if you can find even if it's just 2 points where you can't go from one to the other without crossing the figure, then you're in trouble. For example, I can go from point A to point B. And I don't have to go the quickest way. I can go from A to B without crossing that curve, that figure. The figure being what's in red. I can go. But I can pick 2 points where I can't find the path from one to the other. And if I can't find the path from one to the other, then the figure is said to be closed. Okay. And making a big deal about this, but I think it's important. It's a closed figure. You should know what a closed figure is. This figure, something similar to what I just had, is not a closed figure. Because if I pick any 2 points on the board, I can go from one to the other. If I pick a point here and a point there, I can go between them without going across the figure. Okay, that's not a closed figure. It's an open figure. Make it closed, well then close it. I mean, the word close is very common sense way of calling it. It's a closed figure. Right. So like I said a few minutes ago, a triangle is a closed figure that has 3 line segments. And how do you draw 3 line segments that are closed, that make a closed figure? That's 1 line segment. Second line segment is that. And here's the third line segment. The first one being line segment AB, this side. And the second line segment being BC. And the third line segment being CA. Again, if you're in here and out there, you can't go between the two. Of course, if I only pick 2 points in here, I can go from one to the other. And you may say, what do you mean? This is an open figure, because I can go from one to the other. Like I said, if you can find 2 points, and I just found 2. I can't go between those 2 points without crossing my triangle. That's a triangle. And a triangle is made up of 3 angles. Angle A, angle B, angle C. How else can I call angle A? Well, it goes from C to A to B. C, A, B. How do you draw angle A? You go C to A to B. Angle CAB. Or you start at B and you go to A and then you go to C. Angle BAC. That's angle A. How would you draw angle C? The one up here? Well, here's A again, and here's C, and here's B. The answer is you go from A to C to B. Or you go from C to B to A. Easy case, you get angle C. Angle C is ACB or BCA. Once you have one of them, just read it backwards. BCA. That's exactly what I have here. That's angle C. And really should try angle B on your own, but angle B is angle ABC, which is the same as angle CBA. The triangle is made up of 3 line segments that are closed. So has 3 line segment figure that's closed. But you all know how to draw a triangle. Now you know how to say it a little bit better. Now, talk a little bit more about geometry. These 2 lines, they form a right angle, 90 degrees. Angle ABC, ABC. This angle right here is 90 degrees. You all heard of a 90-degree angle, a right angle. CBD. This angle right here is also 90 degrees. Remember, the sum of the parts is the whole. 90 plus another 90 is 180. This angle is 180 degrees. It's a straight line. Put a dot in the middle, and then you can say that that angle is 180 degrees. Okay, now let's look at a triangle. Let's look at a triangle. You have angle A, you have angle B, you have angle C. Now, first we have to prove something before. My ultimate goal is to prove to you, not just tell you, that sum of the angles in any triangle is 180 degrees. First I'm going to say if you have any two lines, the opposite angles are equal. That is, angle 1 and angle 3, they're equal. And angle 2 and angle 4 are equal. You see what I mean by opposites? Okay. Now, if I were to tell you, so let me erase 1 and 2. Now remember, this is a straight line. So that angle is 180 degrees. If I were to tell you that this portion right here was 10 degrees, then that portion must be 170. And how do you get it? How do you compute it? You do 180 minus 10. If on the other hand, I told you this angle was 40, then the rest of the angle, it would be whatever 180 minus 40 is. And if I told you, although this is hard to believe, if I told you this angle was 140, then the balance would be whatever 180 minus 140 is. The point I'm getting at is, if one of those angles is x, then the other one must be 180 minus x. If I say this angle is x, well, if you have x, what do you do to get 180? Well, first you take away x, that's 0, and then you add 180. Let's make it look like 180. Or probably a better way to convince you, if you have 180 and you take away x, and then you add back x, you get to 180. So if one angle is x, and the other angle, in order for them to add up to 180, must be 180 minus x. This angle right here is 180 minus x. Remember, these two add up to 180. Okay? Now, let me erase this. And let's talk about angle 3 now. We know that that angle is 180. Well, if this piece is 180 minus x, then the other piece must be x. Because when I add them, they should add up to 180. And we keep coming back to here. They add up to 180. All right, angle 4 now. Angle 4. This is 180. Well, if this piece is x, what do you add? And when you add this on, you're supposed to get 180. But I know what to add to x to get to 180. It's 180 minus x. And what do we learn here? That this angle and its opposite angle, they're both the same. They're both x. And this angle and its opposite up here, they're both equal to one another. They're both 180 minus x. Opposite angles are equal. Opposite angles are equal. And we're going to use that. We're also going to talk about parallel lines. If these two lines are parallel and they're cut by what's called a transversal, anytime you can draw a Z, and sometimes you draw a Z that way, on the side, backwards, anything that's a Z. Here is a Z. There it is. Those angles are equal. The angles trapped inside the Z's, they're equal. However you draw the Z. If these two lines are parallel and they're cut by a transversal, well, this is a Z. Here is your Z. Those angles are equal. Any way you can draw a Z. And you just have to be fair and understand that that's the z as well. You know, here you had two parallel lines cut by this here are the two parallel lines cut by this transversal. Here is a z. This is a z. And those are the two angles in that z. They're equal. And I think that's enough to prove that a triangle always has 180 degrees. Regardless of the shape of the triangle, the three angles will add up to 180 degrees. Okay. And this is what's called a construction proof. Through point C, I'm going to draw a line parallel to AB. It's going to be parallel to this line segment. I'm going to draw that. Now, here's one z. Here is a z. This angle is A, so then that angle is A. Okay? Now there's the second z. A, B, C, and then to the right. Like this. So those angles are equal. But this angle is B. Well then, so is that angle. And of course, from the very get-go, we are calling that angle C. Now, I know one thing. That's a straight line. That's a straight line. Adds up to 180 degrees. It's 180 degrees. But it's made up of three parts. It's made up of A, and C, and B. Well, you should know that the sum of the parts equals the whole. You add up the three little angles and you get the whole angle. So from the top, angle A plus angle C plus angle B, in any order you write it, that's 180. I wrote it down here in alphabetical order, but it's 180. But wait a minute, wait a minute. Let's just go back to the original triangle. Let's go back to the original triangle. Let's go back to that original triangle. And we're going to be amazed at what we see. We're going to be amazed at what we see. The triangle is made up of three angles. Angle A, angle B, and angle C. Oh, those three angles add up to 180. And that's what we set out to prove. That the three angles add up to 180 degrees. And that's pretty much the flavor of what to expect. You're going to prove a lot of theorems. Okay, thank you. I hope this was fun.